This video is going to focus on dividing radicals. Even though it's dividing radicals, the directions they use usually say rationalizing the denominator. So let me get you to look at an example. 5 over the square root of 6. The reason it's sometimes called rationalizing the denominator is square root of 6 is an irrational number. Okay? And so what you got to do for something to be considered simplified, it can't have a radical in the denominator. So what you do is you figure out how to make it so that you can get rid of that radical. So the idea, if it's a square root, the idea we can use is this. We can just multiply by the square root of 6. If we do that on the bottom, though, we have to do that on the top, so we haven't really changed the problem. We've just changed the name of it. So 5 is an outside, 6 is an inside. So that would just be 5 square root of 6. But see how both of those 6's are inside? So you really have square root of 36 down there. Okay, so that means that the square root of 36 you can simplify to just 6, and you have 5 square root of 6 over 6. And that turns out to be the final answer. That's the simplest radical form. You have to rationalize the denominator. Used to be an irrational number, but now number 6, just the number 6, that's rational. Okay. All right, and then the other type you might see looks like this. So you might see one like 21, where you wind up having 2 terms. Okay. And in the denominator. And so if you try to do something like just multiply by the square root of 2, that's not going to work. It's just going to bring the square root of 2 over to that first term, and you won't be getting rid of the radical. You won't be rationalizing it. So we're going to do, if you remember back at this result we had, let me see if I can get it to go down. Okay, so I wanted you to kind of be able to think about that previous video and when we when I did the what if, where I had 1 minus and 1 plus, but everything else was the same, and we had the radicals go away here. This radical became just 2, and at the very end, we just had a nice rational number. Okay, we're going to use that idea. Okay, so what we're going to do here is we're going to multiply by not just 1 term, but 2. We're going to use the exact same thing, but in the middle, we're going to put a plus. Okay, we're going to do the same on the top. Okay. All right, now, when we do that, we're going to wind up having on top, we're going to have the 5 with 6 plus square root of 2. But in the denominator, we're going to go ahead and FOIL that out. I'm leaving this in factored form because I'm going to have to check later to see if there's something that can cancel out. So it's better just to leave it in that factored form. Okay. All right. So in the denominator, when we do this, we're going to have 6 times 6, which is 36. Then 6 times the square root of 2, which is plus 6 square root of 2. Then here we're going to have minus 6 square root of 2. And then the negative square root of 2 and the positive square root of 2 become negative. Square root of 2 times square root of 2 is square root of 4. Okay. All right, now notice what happens. These are opposites and they cancel out, and this will be just 2, won't it? Okay, so you really wind up then with the 5 times the 6 plus the square root of 2 on top, and you have 36 take away 2, which is 34 on the bottom, and 5 and 34 don't share anything in common. So this is your final answer to that problem. Okay, so but you could write it either in factored form, and that's 100% correct, or you could distribute the 5 like that, and that's 100% correct. And that's all there is to that. So dividing rational expressions, really primarily, we're talking about trying to rationalize the denominator. Make sure that in the denominator of your final answer, you have a rational number, no radical in there anymore. Okay.